Hey, welcome to Beyond the Forecast. You can see my globe over there. Look at that. It made the shot already.
Oh, that's cool.
Is that our new prop?
That's going to be the prop I'll use later on. We're going to be talking about a lot of different things here on this episode. Welcome, Christy. Welcome, Brian, to Beyond the Forecast. We're going to have some good stuff to talk about today.
Yeah.
Especially with kind of what just happened recently.
Yeah.
Too.
We're going to get into earthquake stuff here in a little bit.
Mm-hmm.
But we're going to start off with this month, even though where we are, at least on the day of this recording on the 30th, we are below average for rainfall for the month, but we've had some days where we've had some heavy rainfall and we've had some flooding problems.
Yeah.
And that's a big issue for some parts of our area.
Especially, Norfolk, Portsmouth, the high density population areas for sure.
Yep.
Where the water can't drain as easily.
Yes.
The rural areas takes a little bit more for those areas to flood, because you have more outlets for that water to go, which we'll talk about that, the urban and kind of rural area flooding in a little bit. But yeah, the heavy rainfall, especially for the south side recently, it's been pretty big.
And Christy, you've lived here for several years. You've seen the different types of flooding we've had here. We can have urban street flooding or tidal flooding, and we're not so much focused on tidal flooding right now.
No, yeah, we've just had a lot of those storms that have to rain themselves out. They just didn't really move, or they were very slow moving, and they produced a lot of rain and a lot of moisture in them. And that just led to a lot of flooding. I mean, we're pretty much at sea level, so you just don't have anywhere for that water to go.
It's kind of a good thing in a way for our area being relatively flat, because when we get flooding episodes, we won't have, like a flash flooding episode won't be as dangerous for us compared to an area that's very hilly.
The Northeast U.S., whenever a tropical system, I forget, what was it, maybe it was Irene, 2011, really big rainfall. All the water falling in the mountains funnels into the valleys. So we're luckily for us, we don't have those kind of big features to kind of, pull water into a certain area.
Yeah, we don't get the moving water situations where that's where you can get the fatalities.
Yeah.
You can still get them in areas where there isn't moving water. Certainly that can happen as well. But for us, we don't have the rushing water. You have to really head to Williamsburg or Surrey County where there's more rolling hills.
Right.
There's not a lot of mountains in this area. There's one, but there's not many. So
yeah, you're more likely going to drown your car.
I picked up on that,
instead
Jeff.
of yourself.
Yeah, Mount Trashmore. There's one mountain. Yeah, there's one mountain in this area.
I didn't catch on to that. I was
I was waiting for the
in
Jeff
the back
joke.
of my head, I was like, what mountain do we have? Mount Trashmore.
Look, everybody,
Trashmore,
Jeff tries to get us at least once an episode with his Jeff jokes. I caught it right off the bat that time.
It was cool. It was even snow-capped earlier this year, too, so that was neat for a little
That's
bit.
not a lie. That is not a lie.
Except the snow melted on top of the mount before it did anywhere else in the shade.
Yeah.
Anyway, we're just having some fun. But no, flooding, big deal. So let's talk about urban flooding and why these areas happen more. Brian, take it away.
It really all has to come down to what the surface is made of. Obviously, in your urban areas, we're going to have our concrete. There's not as much natural, there's not as much nature, I should say, around us to help to kind of soak that water into the ground or run it off. A lot of times in these urban areas, you kind of rely on your sewage system or your drains in big city areas to kind of get that water out of there if it kind of piles up in some certain spots. Think of the underpasses kind of around Norfolk and Portsmouth. That's some of the most common problem areas where water can really kind of pool up. And unless we have a way with our drainage systems to get rid of it, it's just going to continue to rise. Whereas in rural areas, that ground can help soak in that water a little bit easier. The surface is more I think the word is porous. Am I saying that right? Porous, where the water is able to drain through the soil a little easier.
Yeah.
I think that's the word.
And there's there's a science of soils, and I did not focus on science of soils during my meteorology. That was more of an ag kind of focus, but a very hard or a very dry soil that's hard pan caked, that won't absorb the water as well as a soil that has a little bit of moisture in it. It's kind of interesting how that works.
Yeah.
Would the word porous, maybe that's the right word. I don't know what the technical term would be.
I can't remember what the technical term is.
Quality.
But you are right in saying that harder soil, and this is actually why it's bad to get really heavy rains after a long period of dryness, because the water is going to be kind of hard, and it's not going to be normal soil at that point. It's going to be really tough to get water to drain through it.
You'll get runoff is what you're trying to say.
You'll get runoff, and it runs off into certain areas. In the rural areas, it'll be the streams, the rivers, and the lakes. In urban areas, where does that water go? the lowest possible point in those urban areas, which is why we get some flooding in sometimes in our local neighborhoods.
Yep.
In rural areas, it has just much more outlets to kind of run off to, aka rivers and your streams, hopefully away from any development.
Viewers know that I was here for a couple of years, and then I went on sabbatical. I like to call it. I went up to Minneapolis for a couple of years, but I say sabbatical.
Sabbatical.
Fun. And then I came back. When I came back, I rented a house for a year before I could figure out where I wanted to live again, kind of get my housing situation figured out. And that yard flooded and stayed wet very often. So this was an area. This was in this rental house was in Chesapeake. It was in a development that probably 30 years ago was just swamp and trees.
Yeah.
So there was not much area for this water to drain. There was a central pond that the community surrounded, but the water didn't go necessarily into the central pond. It just kind of stayed in our yards. So that's when I learned about there are ways you can get rid of that using a French drain and other drainage methods in your yard. So not so much of a rural type of aspect and not so much urban street flooding and urban flooding, but it is kind of unique in this area because our ground could be clay, so that doesn't absorb the water. That water just sits on top of that.
Sits right on top.
And if you live in one of those areas, I mean, that's what you're dealt with. That's what you got to deal with in your yard, and it can be tough, especially if you have dogs.
Oh, totally.
Yeah.
It can be really tough.
Yeah, my dog, she turned 10 and decides that she likes to play in the mud now. So that's always a fun experience whenever it rains. But I do think that it's interesting in this area that you can go like a few blocks over and then you have a lot of that flooding that happens versus where you are. So it's not, I feel like other areas across the country, it's more like, okay, this area, the whole area will see a lot of flooding. But here it really depends on where you are. Like I was pet sitting for a friend that lives maybe 6 blocks away from me. Where I was, perfectly fine, didn't have any flooding, went to that neighborhood. I had to park a block away because you couldn't drive because the whole neighborhood
like a little
street
microclimate.
was just, flooded.
A little microclimate of where that water can go.
Totally. Got to give a shout out to all the local city emergency managers. We've had one of them on the show, Ricky Matthews, a couple of months back now, talking about know your zone, know your flood zone.
Yeah.
So definitely just search that, know your zone, and it'll take you to the page so you can figure out what flood zone that you live in. That's important for everyone to know.
And not just for storm surge flooding, rainwater flooding, which can happen at any point of the year. So important stuff.
Yes, it is. Let's talk about what do we have here on this board right here. So flooding at risk areas.
Okay, so this, if we play out this graphic, this is kind of just going over some of the most at-risk areas in Hampton Roads. So those urban, low-lying communities, the underpasses, parts of Norfolk, and also really into areas around town. That water can really pool up pretty easily with not many outlets. So during heavy rain events, if you don't need to travel, best to not travel at all. The rural areas, those country roadways, if they're kind of near rivers or like mini streams that on a typical day would just be water kind of trickling down onto the roadway, those can be totally washed out if we get a big enough rainfall and enough runoff. So it's very important to kind of understand the surrounding parts if you live in a rural area, to understand the surrounding parts of those roadways and know, okay, hey, there's a stream here. Maybe if there's a really heavy rain event one day, we'll try and go take an alternate route, because you never know how high that water can rise in a short amount of time.
And the thing is, too, even if you've lived in this area for 20, 30 years, and you know that County Road B always floods when we get heavy rain, you know that during the day because you see it as you're driving up. But you could be driving home at night or it's dark out and there was heavy rain 2 hours ago, and you're maybe not totally aware that there's that one spot that floods. You could drive right into that at full speed, and then all of a sudden you're in danger. So you got to be careful about that.
A great story I have is back when I was in Savannah, one of the first tropical systems that I was covering. I think it was, what was it, last year, Debbie? I think it was Debbie. It stalled for 3 days over our area in southeast Georgia.
Okay.
And some areas got 1.5 feet of rain.
Wow.
And there were some people who were saying they never experienced flooding in their own backyard, but in that storm, it happened because what happened was they had no idea there was these little streams and creeks, maybe in the woods behind their house. All those streams and creeks over that 3-day span, runoff came in, filled them up, and eventually spreading into their yards to the point where they had to evacuate. So that's, sometimes the danger for rainfall flooding. And this is, even lasting after the storm. It doesn't happen, right away. it can be 2 to 3 days down the road when all that water runs off into those streams and creeks and eventually starts to rise. And that's not even storm surge. That's just from the water that's raining. That's, that can happen in a typical thunderstorm if it rains hard enough.
Yes, it can. It definitely can. Flooding can also happen too when we have, or can be a problem when we're walking, driving through that water. Obviously, you don't want to be walking or driving through the water when it's certain depth.
Definitely not. Yeah, just a foot, that can be enough to float away a small car. So that's certainly something to take note of. And any higher than that, in your big trucks, your minivans, your heavier vehicles can start to get floating and then drifting away. Again, we saw it with that tropical system that I was just talking about in Savannah. There were some people who lost their vehicles, and not even that. Even if their car wasn't, floating away, they still got the water came up high enough that the water got in their cars.
Right.
Just sitting there.
And the rainfall rates that we get in the summertime, that's where the problem is. It's
intense.
It's not so much the wintertime or the spring. We don't get those thunderstorms, so we don't get the 2-inch per hour rainfall rates. We get that more so happening summer, maybe in tropical season events in the fall.
Because our air is just so humid. It's just got so much water in it. Because it's so much warmer out. The warmer that air is, the more water that atmosphere can hold. So that all that rain coming down.
Precipitable water.
Yes,
Remember that term?
a big term.
I love that term.
Yes.
So how much water is in a column of air? So from where we're sitting right now, where you're sitting, where you're watching this, you look straight up and you go to the top of the atmosphere. How much water would be in that column or that tube above you? So if you were to get it all out and you were to extract out 2 inches.
Pretend you're taking a squeegee, and just wringing it out. What's the maximum amount of water that you could squeeze out of that column of air above you?
Yes. Yeah.
That's what we talk about when we talk about precipitable water.
So if it's above 1.5 inches, that's usually when we're starting to get more concerned for flash flooding
We've had
events.
we've had a couple days this summer where it's been over 2, close to 2.5.
Yes.
Yeah.
And those are the days where, lo and behold, the flash flood warnings get issued.
Yep.
I don't know about this. Does the dew point outside, would that correlate with PWATS, precipitable water?
It
kinda. Not
think
really.
it might it might in a way.
bit.
I think those days where we did have the precipitable water levels over 2, I'm pretty sure, thinking back, I wasn't looking directly at the dew point measurements, but I'm pretty sure those were really sticky days. So it's very possible.
Yeah.
Dew
Well,
point's
I mean,
just
it
the
makes
measure,
sense.
the
Yeah.
measure of how much water vapor is in the
Right.
atmosphere.
Yeah.
You need water vapor for that rain to occur anyway.
Only measured at a 2-meter height.
Right.
True.
Yeah.
So what is
That is
it?
true.
What is it going up?
Yeah.
Is it is it a very saturated column going up? SQT is a good thing to look at there.
Yep. Yep. Have you ever launched a weather balloon?
In
time.
college, yeah.
You got to launch a college,
One time.
Penn State, yeah. Well,
Yeah, we get
I'm just
that
gonna switch it on
nice
this camera
little
because that's the only
experience.
one.
Yeah.
That matters.
High five.
Wait, no, let's get the high five back.
five.
Okay.
Yeah, there we go. Yeah. Oh, that's cool. It was like in between the box.
Right in
was
between the
cool.
box.
Anyway, no, that's cool that you got to launch a weather balloon. I've seen one launched. I was not allowed to launch it because it was too windy at the time. There was like a 30-mile-an-hour wind. This is at Wallops Island, so couldn't launch a balloon that day.
Yeah.
But they launch, obviously, weather balloons launch twice per day at that location. When there's rocket launches happening, they'll launch more weather balloons, but it's not so much NOAA that's launching them. It's more of a NASA thing that's
Got it.
launching them for the clients that are sending their rockets up, because you have to know what that wind shear is in the atmosphere. So the rocket's not screaming up and it's hitting a high shear environment, because that's not a good thing for a
Can
rocket.
rip
makes
apart a
sense.
rocket.
Yeah, just like when we're flying an airplane, turbulence.
Yeah.
You don't want
Yep.
that when you have rocketry going on. The shear levels depend on the size of the rocket, things like that. They're kind of secrets though too, because it could be related to military secrets or related to the company that has them as well. Because
also these-
they don't want to release that information.
Right.
Right.
But also these, weather balloon launch is super important for, the rocket stuff in general, because think about how much money it goes into some of those.
Lot of money.
One rocket launch,
Yeah.
millions of dollars, some billions sometimes, dare I say, definitely millions of dollars.
Well, there can be spacecraft on board that would be that much in terms
Right.
of how much time for development.
Exactly.
And going back, you could add it up that way. But yeah,
So that's
they're
why it's
millions
so
of dollars.
important. So important that,
Yes.
they get it right. The forecast has to be right.
Yes. It is great that we have Wallops Island where they launch weather balloons, and we have a launch pad right there, so you can kind of see like in the morning, oh, there's a lot of shear in the atmosphere. I've done that before when I'm going to watch a rocket launch. If it's sheared out in the morning, I probably won't even try because
to head up there.
Yeah,
because you just have a feeling it's going to get canceled or called off.
Get a scrub launch. Sense. So that can be frustrating. So I have a couple of numbers that I've written down in thresholds amount for kind of things that I've noticed over the times, but I don't have the specific numbers.
That's kind of like me with going surfing. I'm not going to the Outer Banks unless it's this height with this wind direction.
Right, and that swell period maybe too.
Exactly.
So, totally. That's all about flooding. So I think we're going to take a quick break, and then we're going to talk about the July temperatures. We're also going to talk about the recent earthquake that happened in Russia that has some concern for spots into the Pacific Ocean for tsunamis.
Yeah.
Brian's going to lay down his tectonic plates knowledge, so we'll be right back in just a bit. Welcome back to Beyond the Forecast. I think this is the only camera that can show the globe.
You got it.
Yeah, you can spin it on your finger if you got your hand just right. So we're talking about, does this work? Well, I'll just put it right here because you can still see it.
Covers the whole.
Great camera shot there, Jeff.
You just said that. Oh, that's really close.
Yeah, that is really close.
Here, let me move this back, and then we can do this. So we're talking about tectonic plates. Now, this globe doesn't have them on them. You have to get tectonic plates from a map that shows that like this. So this is a map, not a spherical. The United States, North America is right in the center of the map, so kind of get your eyes trained because there's brighter things. And Brian, you're into tectonic plates and ocean bathymetry. So tell us a little bit more about these plates.
So there's a couple different there's a couple different kinds. You have strike slip faults, which you can think about the earthquakes that get caused in California. Those are strike slip. Those are, areas of earth that are moving, kind of parallel to one another, and the built up stress, because obviously the plates are uneven. There's going to be areas where the stress gets built up a little bit more than the surrounding areas of that plate. And once you get those slips, you get those areas where it's kind of going like this, and once you hit a little bit of stress, there's going to be friction that builds up over time.
Yep.
Once it slips, that's where you get your earthquake. Those ones don't typically cause tsunamis, because what you need for tsunamis is a displacement of water. What we need is those thrust earthquakes, or with the one off the coast of Russia, they called it a mega thrust quake because it hit a certain threshold. What was it, 8.7? Eventually it was turned to 8.8 magnitude?
8.8, yeah, was the later
one
analysis.
of those. I think that's a top 10 that we ever recorded too, if I'm correct.
Somewhere around there, yeah. One of the strongest ones in a long time, certainly.
Exactly. So that was from a thrust fault, or essentially, you have to think of it, if you could pull up the map one more time, we can look at the Pacific plate, and it kind of goes up against the North American plate. If off to the,
So you're looking at this zone right here?
Nope, keep going. The one with Russia, keep going right over there. That's a subduction zone. So that is one area of the plate where essentially the Pacific plate is sliding underneath the North American plate. That typically it's basically the same things happening. You're getting built up stress as that plate is subducting. And once it slips and releases that stress, you can get an upward thrust. That's why they call it a thrust, a thrust quake, thrust fault line.
And don't mean to interrupt, the area of interest from the earthquake is right here.
Right over there. So
that's
the yellow plate, the Pacific plate, is sliding underneath the North American plate, the brown one there. And when it slipped, you got a whole bunch of force going upward. That is water being displaced, because obviously you can't lift the ground under the ocean without also lifting the water that's above it as well. So that's what creates those bigger tsunamis. The one in 2004, I believe it was Thailand, I believe it caused over 200,000 fatalities.
Jeez.
It happened right off the coast. It produced a massive tsunami wave. And at that time, we didn't really have, the best ways of kind of talking about the risks of these earthquakes. Now our technology is a whole lot better, so we're able to kind of get the warnings out ahead of time. For example, the tsunami warning sirens going off in Hawaii yesterday evening, and even into California as well, hours in advance.
But this was focused again right around
here where.
But these were the spots that had the biggest concern early on. It was areas in Japan.
Yeah,
the Aleutian Islands had a warning at one point.
And that's where the wave got there much quicker because it's closer to the epicenter. These waves can, they can go up to 500 miles an hour.
Right, 500 miles an hour for a tsunami wave.
So that takes it into the Aleutian Islands there in
hour and a half.
Hour and a half. Japan, maybe closer to 2.
Yep.
Yeah.
Closer to
Takes
2
a
hours.
couple hours to get to Hawaii, but again, it's these kind of there's strike slip faults, there's just normal fault lines, and then there's diverting plate boundaries. There's a whole bunch of different kinds of fault lines. Not all of them create earthquakes, by the way. So they'll have tremors, but not all of them will produce the big time earthquakes where you get the tsunamis. The Ring of Fire, though, in the Pacific, that being your fault lines off the coast of California, where you have those kind of strike slips, and also the subduction zones. Those ones are the ones we really look at for the one, biggest tremors, the biggest earthquakes, and two, for the risk for tsunamis. 3,000 miles away, basically, from the epicenter to Hawaii, so you can imagine takes a couple of hours to get there. But we did see yesterday, I was actually looking at some of the surf line cams, really cool to see, water receding over time.
Yep.
The reefs becoming bare and dry.
Exposed.
Also, Surfline actually posted something. Turtles, unfortunately, getting dry docked on the reef.
Whoa.
Because the water was sucking out.
They couldn't move fast enough.
Couldn't move fast enough, or it was just going slow enough that they were just kind of hanging out there on the surface, and all of a sudden, whoop,
There they go.
Water is out.
So the thing that I'm kind of wondering too, when I drew this map on this screen here, let me just pull it up so I can reference it. So when I'm showing these arrows, remember, the wave is going to travel the direct distance. It's not going to go down and around. It's going to go the direct distance. I'm noticing that the Aleutian Islands are kind of blocking, they're almost shadowing parts of North America or the United States, which is interesting. So that's why I pulled the globe back out here to see. So if here's Washington State right here, and that peninsula in Russia. So you would have to cross this way. So the distance really isn't that much different than it is to go to Hawaii, which is right here. They're relatively close.
You have to also think
distance.
about when it comes to a wave, whether it's a tsunami wave or just a normal wave. Obviously, with a tsunami wave, the energy, there's so much energy because it's caused by that thrust of the earth upward. And so you have a ton of energy from the ocean floor all the way to the crest of that wave. So even a tsunami that's 3 feet in height, maybe up to our waist, can have the energy of the entire ocean beneath it. So that's why, they're so strong. But this all comes down to kind of bathymetry and then the shape of a coastline. What we have to think about, in areas where there's a bay, waves are not usually as big as areas where you have headland. We call these point breaks in surfing. They tend to catch surf a little bit better. When it comes to a tsunami that's traveling across the Pacific, there's not going to always be areas that actually see a physical wave coming ashore. Mainly the waves are going to be for areas that catch the surf, that catch the wave, areas that stick out a little further. You can think of them as a catcher kind of reaching out, baseball player reaching out and grabbing the ball. That headland, that area of land that's sticking out a little bit further is catching the wave. So in many instances, you can't even notice a tsunami unless you maybe throw up a time lapse. You see the water come out and then slowly surge
like
back
surge.
in. Exactly. A lot of times it's a surge and not so much a physical wave. So in areas of the coastline where it kind of reaches out and grabs the water a little bit more, your point breaks, there could be a bigger wave there. That's, I believe, from some of the buoys off the coast of Hawaii, they actually measured it at around 6 to 7 feet. But again, not all of those areas saw an actual wave. It was more of a surge.
So this is from NOAA right here, and this is looking at the characteristics of a tsunami. So if you're on a small or a large craft or small craft in the middle of the ocean, you're not going to notice it because the height of the wave is very subtle, or the change in the height of the ocean, you're not going to notice that. So the bathymetry, that's the study of the floor.
Ocean floor, yes.
So as that gets higher or shallower,
as it gets shallower,
it amplifies the wave or the water.
Because essentially you get interactions with that energy flowing. Think of a tsunami. From the crest to the ocean floor, you have all that energy rushing towards a coastline. What happens when you enter the shallow water and that energy at the bottom has nowhere to go? It's running into the ocean floor. It has to go up. As a result, you start to build that wave a little bit taller and taller and taller, and to the point where eventually you have so much friction at the bottom, kind of slowing down the bottom of that wave. The top of the wave is still moving the same speed because there's not as much friction. That's where you start to get your cresting wave that eventually breaks. It's the same kind of science when we talk about waves surfing, as is the science behind a tsunami wave, if there actually is one that breaks there too. But again, it's not always going to be a wave. In some tsunamis, it's a surge. It's a surge of water over, sometimes a couple of hour span. And those ones could be just as destructive as, a physical set of waves.
This is a cool website that I found. This is again from NOAA. So and I can't make this image larger. I tried clicking on the link and it took me to another page. But you can see this is from the tsunami from 2010. Tsunami energy. So there was an earthquake and activity that happened off of South America near Chile.
Wow.
And that sent the energy across the entire Pacific. So you can see how all of these locations and all of these little red triangles that you see here, they're really small. I apologize for that. But those are all the buoys from the National Data Buoy Center. So last night they were in tsunami mode. If you went to that website, they were actually flashing.
Blinking. They were blinking.
Yeah, and I've never seen that before. Oh,
Okay.
tsunami mode.
Oh, and I got a question from my parents back home. They were really curious as to if we had something like this on the East Coast. If you go to the National Buoy Data Center's website, we have these buoys for the East Coast as well. They're just obviously not blinking as much because we don't have those kind of tectonic plates off of our coastline. If we could pull up really quickly the map. Yeah, here, we'll look at this real quick.
Yeah, I was trying to load it.
The East Coast.
You're fast.
Sorry. See them blinking there on the West Coast?
See, they're blinking.
Yeah.
Yeah.
Look at that.
So that's where they're detecting that. If you scroll down too, I believe it'll tell you about, see?
Right here, Tsunami
is
Station event mode.
in event mode. If you go to the East Coast, you notice they're not blinking. Usually they're not whenever we look at this because there's not the tectonic plates, the North American plate and the African plate. Look in the middle of the North Atlantic Ocean there. That's a diverting plate boundary.
Oh, so this right here, this line.
So that's a diverting plate boundary. That's essentially two plates that are moving away from each other.
Creates a trench in a way.
It more so it's creating new land. You have hydrothermal vents down there, volcanic activity creating new land. You actually, if you kind of look through, you can kind of see the depth charts. I believe it actually kind of rises in a few spots along those boundaries because you're again creating new land. You have those hydrothermal vents pumping out magma, and that magma interacting with the water. It creates rock.
It's actually a ridge.
It's a ridge, exactly.
Yeah.
It's kind of a mountain chain underneath the water.
Yep.
But those are diverting plate boundaries, so those are moving away from each other. The North American basin or the North American plate is moving to the west. The African one is moving in the opposite direction, off to I believe the south and east. Let me pull this up so I'm not.
That's fine. Yeah.
Totally wrong here.
One thing that's great about these, and
Christy, it's moving east, so they're moving away from each other.
You've used this before. You used this website to look at buoy data, or at least wave heights with hurricanes.
Yeah.
It's great because you can look at the details of this. If you've never used this page, it's great. You can see the details. You can see, hey, that's what the buoy looks like, and you can see some of the data that's real time or the historical data as well by clicking on these charts. Obviously, changing a pressure for hurricanes or tropical systems, you'd be looking at that. But if you want to see wind speed or wave height, WVHT.
It's big for the surfers, this one.
Yeah, you can see that right there and you can see the chart. So yeah, this is raw data, raw charts, but everyone can read this. It's just a chart with the x-axis being your time, the y-axis being your height, your feet. It's fairly simple. This one doesn't have much for wave height because there's not much activity out there, but it's a great web page to see what's going on in the ocean. When there's a hurricane moving through this area here, you can see what the buoys are showing, and we lose buoys often. They can either get disconnected and off they go, or they can get damaged by the waves.
Because you have
to
think, a hurricane is the strongest it's ever going to be over the water. Less friction, less limiting factors. Those buoys are at the mercy of the ocean when they're going right through these big hurricanes. So you have to think, there's sometimes waves that are 40, 50 feet inside of a hurricane, and especially close to the eye wall where you have winds 100+ miles an hour.
Right.
Yeah.
Those buoys are getting ragdolled.
Yeah.
It's windy. This is fascinating stuff. Did you know he knows all this stuff?
I didn't. That's impressive.
Look,
and
there's a lot of salt water that gets stuck in the ears here, but still
No,
remember
cool.
take for anybody listening, if you're still working through high school or even college, take an earth and mineral science class. It's so much fun.
It's
Yeah,
cool
You learn
I took
so
a
much.
natural disaster class in
so much.
college, and it was cool. We talked a little bit about earthquakes and tsunamis and all that stuff. Maybe not as in depth as that, but
Right. Not as much.
But it was good.
Did you watch the show the cartoon Captain Planet?
no, I did
Oh,
not.
you didn't watch the show?
No.
Brian, did you ever watch the show?
Uh-uh.
Oh, okay. Well, that joke didn't work. All right. Well, anyway, I was just going to say, so Captain Planet, to spawn or create Captain Planet, you have all the Planeteers, they have 5 different rings. And you would be Earth, because Earth There could be fire, there could be wind, water, or heart. So you would be the earth because you know everything about the earth. You would spawn on the earth, and then the mountain forms.
That's awesome. That's
Anyway,
a cool.
You gotta watch the show. You gotta watch the show.
Now I have to. Now you put me on. You put me on the spot.
Awesome. Yeah. Anyway, we'll be back with more. We're going to talk about the July climatology. Christy's been crunching the numbers on that. We're going to talk about how warm and how cool it's been, and rainfall-wise, we'll look ahead to that. So we'll have more coming up. Brian's going to disappear. So thanks for joining us, Brian.
Of course.
We'll see you for the next one.
See you guys.
Yeah, we'll see you for the next one. By the way, the next episode is going to be all about your questions, viewer questions. So start
that'll be a fun one.
Those are always fun.
Post them to us. We'll be excited for it.
Yeah, so we'll be right back. Hey, welcome back to Beyond the Forecast. Christy's hanging out with me. Brian had to leave. He had to get ready for the show. So.
Yeah, that's fair. We'll give him an excuse.
Yeah, we'll give him an excuse. Well, he took the workload on the earthquake stuff, so we had to.
Yeah, and that was very interesting.
Wasn't that something?
Learned a lot about all the tectonic plates and everything.
Did you watch? Okay, I'm just going to be going down memory lane again. Bill Nye. You watch that show?
Yeah.
Like they wheel the TV in the classroom.
Oh yeah,
like
yeah. I met Bill Nye in person once too.
Okay, tell me that story. Want to hear about him.
That was at Penn State.
Okay.
I don't remember what he was there for, but he was there and he obviously stopped into the meteorology department. And yeah, I think whatever he was doing was more of like a private event. And I had run into him. I was going up to do my campus weather service, and they have the bathrooms right by the elevators. So I literally almost collided with him when I got out of the elevator and he was leaving the bathroom.
Okay.
So not the greatest, I guess, interaction,
Yeah,
but I still met him in person.
That's cool. Got to meet him. Yeah. I remember the episode that he did a long time ago about tectonic plates. Where
Okay.
he had like a big pool and he had like giant floating foam plates for the Earth to kind of show how the tectonic plates were. So that's kind of my only knowledge of it. So Brian just opened that world up a lot more to me.
Yeah, no, that was cool. And I think it was more interesting to me. I mean, I knew about all the different plates when they're colliding and stuff, but the diversion and then how that creates a ridge and mountains and stuff,
Right.
like
I didn't
that's
know
pretty interesting. And I didn't know that that's kind of where we are on the East Coast. So we, I guess, have a little bit of a lower risk of seeing some of these tragic tsunamis and earthquakes.
Yeah, which is great because a tsunami risk for Virginia Beach and for Hampton Roads would be pretty scary.
Yeah, that'd be really bad.
Because the beaches in Hawaii, the beaches in California, not all of them, but a lot of them, it's cliffs.
Yeah.
So they don't have the effect of the tsunami wall. We don't have cliffs on our beaches anywhere. So
yeah,
it'd be kind of
I don't even know if we have anything in place if we were to have a tsunami. Like I know some areas like New Zealand and stuff, and I'm sure in like Japan and everything, they have higher ground areas that are built. So if you have the tsunami warning go off, obviously you need to go to higher ground, and these are specific structures that are meant to withstand a wave, and you go all the way up to the top.
Right.
So I don't know that we really have that here.
Yeah, well, we have one mountain, so we have Mount Trashmore.
Everybody go to Mount Trashmore.
Everyone go to Mount Trashmore. Yeah, King of the Hill.
Yeah.
Maybe not the ideal situation.
Probably not.
I was watching some of the local news. We're going to get into the July Climo stuff here in just a second, but the local news from Hawaii last night from one of the stations there, the people that were at Waikiki Beach were advised to go back to their hotels and to get at least to the fourth floor. Mm-hmm. So not just get inside, get 4 floors up, which is significant.
Yeah, you do need to be really high up there. But I guess those hotels, I'm sure, they're probably built to withstand some hurricanes. So if you think about it, if you have a wave, I mean, obviously you're going to get flooded out. But if you're up there, I would imagine they're probably built so they don't at least collapse under that type of event. Yeah,
that type of force, because that water moving is a lot of force. Let's talk about some of the Climo stuff here from the month of July. So it's been a warm month.
Yes. Closer to home, I think people might think that this has been a really hot July. And so I have a calendar here that has all of our temperatures, our high temperatures that we've seen. And this is, I think, a great example of how you hear a lot of people say it's not the heat, it's the humidity.
Yes.
And that's really what we've been suffering with throughout this past month. So if you look at our temperatures here, we have a lot of 80s, low 90s on there. I mean, our average high is like 90 degrees for July. So seeing like a 92, that's not that far off from average. In fact, most of the days were a little bit below average for our temperatures. I'm looking at one of the charts here that shows you kind of which ones are above and below. And I'll count real quick. 1, 2, 3, 4, 5, 6, 7, 8. We had like 9 days above average, which is not...
That's not that much.
A lot. especially compared to how it's felt, because to me, it's felt like this has been one of the hottest Julys, at least that I've experienced since being here. Yeah. And I was here since 2021.
It's not the heat, it's the humidity.
Right. And
wow.
So I tried to look and see if there was anything that has the heat index, like the peak heat index every day. And I don't think that we have anything that's readily available for us that has that listed per day like we do for temperatures and rain and all that stuff.
It's just like for the wind chill. There's not really
right.
a record of that.
Yeah, we don't really have a record of like wind chill or the heat index. But that is really what has been impacting us, because we've seen so many days where it's felt like we're over 100 degrees because our dew points have just been sitting in that tropical, that saturated level of the mid to the upper 70s. So very hot. And as far as let me have you go back a little bit into that temperature one real quick.
Okay, yep. Sorry, I was moving too fast.
No, you're fine. So the temperatures, we are on average only about a degree above the normal. So the normal that we usually would experience for the month of July temperature-wise is 81.1 degrees. So that's taking an average of all your daily highs, all your daily lows, and averaging it out that way. So our normal is 81.1. Right now, we're sitting at 81.95, which we'll get into that in another graphic here in a minute. So that's really only about a degree almost above normal, which really isn't terrible. When we look at the top 10 lists that I'll show you here in just a little bit, or maybe I guess we could pull it up now.
Yeah, I'm just loading it up right now.
That one you can really see how big of a difference it is. And remember, these are averages, so it takes a lot to have an average go up several degrees. So our top hottest, 2020, 85.4 degrees on average that we had. So 2020 was the hottest that we've seen in Hampton Roads, and I'm sure some of you that are listening and watching, you remember that.
Yeah.
That was a year before I got here, so I didn't experience that one. But definitely made the top of our list. And so we're not even in the top 10 for this year, even though you might think that it is, you might feel that way. But like I said, we're at 81.95. That's only about a degree, 0.9-ish degrees above that average. But you can talk about how the top of our list is like 4.5 degrees above average.
And when we look at average, again, it's a 30-year average from 1981 to 2020.
Yes.
That's that 30-year average for that time. So that's where that number comes from. Temperatures have been warming up. If you were to look at the older average from 1971 to 2010, that average temperature for July was a little lower.
Yeah, it was like 79.8, I want to say.
Yeah.
Yeah.
And the average high temperature, the hottest temperature of the year, the average high, I can't get this out, but the average high temperature today is 89 degrees.
Yes.
The average high temperature 2 weeks ago, let me get this back on camera because I'm feeling like maybe I can talk to the camera better. 2 weeks ago was 90 degrees. So that 2 weeks ago, 90-degree temperature wasn't 90 20, 30 years ago. It was in the 80s.
Right.
So that average high being 90 in mid-July is a newer phenomena and a newer thing from a warming temperature. So.
Right. So again, that is a common thing that we've seen in a lot of places. So that goes into that whole topic of climate change and everything and global warming, is that, you can notice that in these trends where they come out, we see new ones. It's a 30-year range that we always look at. Does it come out like every 10 years or something like that?
Correct. Every 10 years. Yeah.
So every 10 years we see that, and you have noticed that pattern that it's steadily warming as we look at those averages. And again, it takes a lot to change an average.
It does.
Yeah.
For temperatures, for precipitation, those averages are usually fairly consistent. When we get to snowfall for Hampton Roads, it changes every time we get a new data set. This year it went up this last cycle, I think it went up by an inch for the average amount of snow we get in Hampton Roads. And I was super excited, like, oh, wow, we're turning into a snowy climate. It's just the 30-year data set. We don't have enough really good data from
Which
that.
is, it's funny out here because, like, this year we had a crazy amount of snow, over a foot of snow. But then, a couple of years ago, it was just, we had like a couple inches and that's about it.
Yeah.
So It varies. But so talking about precipitation, we can go back to that other graphic.
The calendar?
Yeah.
Okay,
And we can
let me
talk
load that up.
real quick about the precipitation that we saw throughout July. So aside from it being obviously very hot, we did have a stretch where we did see a good amount of rainfall. And we talked about that at the top of the show where we saw some of that heavy rainfall, these storms that just kind of had to rain themselves out. One of those days was on the 10th of July. I do want to say that like the temperatures and the numbers that you're seeing here, the precipitation, that's all taken at the Norfolk International Airport. That is our official record-keeping site.
Yes.
So that's where all these numbers are coming from. So in your area, say if you're in Williamsburg or something, it might be higher for you. So, these are just letting you know where the location is as a preface. But that is our official record-keeping site for Hampton Roads. So we have 1.83 inches of rain that fell on the 10th of July. That is quite a bit of rainfall. And then our next highest was on the 14th of 0.71 inches. I know during that time my grass was growing like crazy, but that already makes up about half of the rainfall just in those 2 days that we saw throughout July. So I don't have it listed on there, but we have had a total of 4.17 inches of rain for the month of July. Our average is 5.6. So we're in a deficit for that rainfall. So it's been drier than normal. We are missing about 1.5 inches of rain, roughly. It's 1.43 if you want to be technical up there. But
it just takes one thunderstorm and you can easily make that amount up.
Right. Exactly.
It doesn't take that much.
As you saw, we saw that amount over that amount in one day on the 10th. So definitely it's been overall a drier month for us than normal, but we have seen still a few days where we had a good amount of rainfall. Then we had some of those drier stretches. I think the bigger story was that high heat and humidity. Very not hot temperature-wise, but it was that humidity that factored in. You got those feels-like temperatures that were in the triple digits, and I know a lot of people were just melting for several days in July.
Yeah, I'm on my second air conditioner so far for this month.
Man.
So yeah, that's
not good.
Yeah, and this show isn't sponsored by any HVAC company, so maybe we should get them on there. So
yeah, right.
We gotta get someone on there to help it out. ACs have been tough. Rainfall-wise, we are down for the month.
Yeah.
For the year. This is not for the average. This is not where we are for the year, but this is looking at when the rainy season is. So for July, we're down by 1.5 inches roughly. We usually get around 6 inches of rainfall in the month of July. This is the rainy season right now. July, August, September. It continues into September because of those tropical systems that come from the Gulf or from the Atlantic.
Yeah.
So that's where we get the 3 months right now. Really 4 months if you want to include June. This is our rainy season here in Hampton Roads.
Yeah, it is. So I'm expecting as we head into August to see some more rainfall out there eventually.
Yeah.
I mean, we're not too far off. I think overall for the entire year, I looked at that deficit and it's roughly about like 1.5 inches. So we're not like in a severe drought or anything like that.
Thankfully not.
Yeah.
The growing season, even though when we looked at that last calendar graphic, we haven't had a ton of rain. It seems like the growing season's been pretty good though for any gardeners that have been doing stuff.
Yeah, I think you've had some luck in your garden.
My tomatoes have been really good this year. I think it's part of it from soil amendments, learning to put more compost and to more just good stuff in the ground in the beginning of the season, but also just the frequency of rain. The tomatoes have been really thriving on that. Just enough rain when we need it, not too much rain when the fruit is ripening to burst the tomatoes. So they've been pretty good so far this year.
Okay, yeah.
They've been good.
That's a lot. Maybe that was my problem. I tried to do a garden a couple of times and it just didn't work out. So maybe I need to take some notes from you.
Yeah, every year there's a new battle. Like the last 2 years, my bell peppers have been stunning. This year, they're nothing yet. So we'll see what happens. They've always taken me longer to grow than my peers. They get them to harvest a lot sooner than me. I'm harvesting them in September. Oh. So I'm giving it some more time.
Okay.
I'm not rushing the plants.
Yeah, you still got a couple months.
Yep, we still have some time.
Yeah.
We still have some time But gardening-wise, it's been so far really well. The zucchini haven't produced yet. I've been having troubles with the vine borers where the little, the flies or whatever, they lay eggs on the vine and then these little grubs and larvae grow inside them and you're picking them out.
Oh, that's not
Maybe
good.
a little TMI, but it's not fun. Anyway, but I think the year has gone pretty well, at least for rainfall amounts. We're
Yeah.
going into August and September. We'll see what we can do with that. We'll see how we end the year. Obviously, we never want to have rain on October 31st for Halloween for the trick-or-treaters.
Right.
So we'll try and keep that day dry. We had July 4th dry this year, so
That's nice.
if we can get those outdoor holidays dry, Labor Day is another one too,
Yeah.
we'll be good.
I think people will be happy.
I think they'll be really happy with that. So what do we have coming up here in the next couple weeks? So in the next couple weeks, we're getting into the peak of hurricane season.
Yeah.
We're also going to be focusing more on daily forecasts here on Beyond the Forecast as well for hurricane season, for more hyper-local forecasts. We're going to be doing that in the coming month. So that's going to be exciting. But next week is going to be all about viewer questions. And I'm excited for that because I have one that's already saved. I don't remember who asked the question. I'll get that next week. But we're going to be talking about why rockets, and we're going to go right back to astronomy, why rockets fly the way they do to get into space. So we're going to talk a little bit about that and try to answer some of the misnomers about that.
Yeah.
And also just kind of make it, we're going to try and do basically a little bit of orbital mechanics here in the CTV area. So
Okay.
in the Wavy Plus studio.
Yeah, that should be fun. It's always fun when you talk about space.
I love talking about that. I love talking about that. I don't have any new telescopes or any new images to share there. A friend of mine does. He's been on the show a couple of times. He's gotten some new pictures and images of Andromeda. So we'll
Nice.
maybe see if we can get some of those pictures to share as well.
Yeah, no, that's always good. It's always fun to get viewer questions and answer them. Sometimes it makes us think a little harder, so that's always good.
I love doing that. What's a good way for them to get a hold of us?
Well, it's our email, I assume, right?
Yeah, our email is fine. Facebook, any way.
Yeah.
Any way you want to do it is fine. So you can send the question in if you have a picture of something and you're confused. You can use wavy.com/reportit to include a picture. You can post them on our Facebook. We'll be asking probably, I would say Sunday or Monday next week. We'll put up a post. Or that could be Sunday or Monday when you're watching. So whatever date that is, let me pull up my calendar real quick. So that would be the 3rd or the 4th of August. We'll probably make a post and just put your question in there in the comments, and then we'll grab all those, and then we'll do the Q&A on our episode when we do that later that week.
Sounds good.
Anything else you want to mention today, Christy, before we sign out?
No, I think we covered it all. I think we learned a lot today.
Yes, we did. It was good to learn more about the tectonic plates and the earthquakes, too, and kind of how our area is a little bit lower risk. So shout out to Brian for that. Thank you, Christy, for helping us out on the episode for today. We will do another episode next week. So thanks for watching.